Thanks everybody for showing up to What's in the Box, Automatic ML Model Containerization. My name is Clayton Davis, and I am the head of data science for Modzy. Importantly, for this particular talk, I am also one of the maintainers on Chassis, which is a free and open source software project that basically tries to take machine learning models that have been generated in just a lot of standard training tools and turn them into containers that you can then use on your desktop, IoT devices, in the cloud, pretty much anywhere you want. I am joined by Saumil Dave. He's the head of ML engineering at Modzy and also one of the maintainers on Chassis. And he is going to be doing all of the really hard stuff today along with you guys. So speaking of today's plan is going to be pretty straightforward. We're trying to pack a lot into the next roughly hour and a half. We're going to start out with a little bit of a pre-work review. We tried to coordinate kind of a pre-work email or notification with the conference out to you guys. I know some of you received it, some of you didn't. So we're going to work through a little bit of the things that you should probably have installed on your system to get the most out of this particular tutorial. This workshop itself is going to require a lot of, basically a lot of kind of browser work. If you want to do hands-on things, we're going to do most of the notebooks in Colab. So everyone will be able to have access to that. But afterwards, if you're actually going to want to interact with any of the containers that get generated and created, there's going to be a few things that we'll ask that you go ahead and install on your computer and have access to. After I go through the pre-work, I'll do kind of a background on Chassis, kind of what it is, where it came from, the problem we're actually trying to solve, and why it's useful in MLOps pipelines. And then we're going to move straight into Saumil, who's going to go ahead and give a just kind of what we would consider to be the hello world sort of version of using Chassis to containerize a model. So Saumil's going to go through just building a quick sklearn model and then turning it into a container and submitting it out for processing and containerization on the Chassis service. Now, Chassis containerization service is like most build processes that you encounter in computer science. It's going to take a few minutes. And so while that's going on, I'll give kind of a quick understanding or kind of a quick overview of what's going on kind of under the hood, both on the SDK sort of client side, as well as what's happening on the service side after you've actually submitted and tried to publish your container. Hopefully by the end of that, the container will be done. It'll be sitting up on Docker Hub, and Saumil is going to go through pulling that container down from Docker Hub onto your local machine and how you can actually interact with your model that you've now containerized locally using the Chassis SDK, which has some built-in communications protocols for gRPC. And then after that, we're going to do a little bit more advanced demo and hands-on tutorial with PyTorch. And so in kind of our Hello World example, there's just sort of the bare minimum. In PyTorch, we're going to show you how you can include not just your model in the container, but also things that you might want to do for more sophisticated models. So we'll say pre-processing transforms for PyTorch, for example, or how do you include not just single inference processing, but how do you include things like batch processing or GPU access? Those sorts of things are going to be included in the PyTorch auto containerization. After that, while that's kind of building itself, Saumil's going to go ahead and show you how to use Postman to make calls to the models. For those of you who are not familiar with Postman, Postman is a piece of software that essentially lets you make no-code API calls out both across HTTP requests as well as gRPC requests. So it's a thing that we'll use pretty frequently when we're trying to test out models if we're trying something new along the way. And then the next hands-on sort of thing that we're going to go through, we've been calling it kind of ecosystem liberation, but what we're going to do is we're going to walk through an example of taking a PMML file and converting it into a container. Now, PMML files aren't necessarily something you see every day for people who are building models from scratch, but they are an export capability for several model training tools. So things like Dataiku. So if you want to be able to take models that you're building in kind of some of these other training tools and then get them out of those ecosystems and into their own container, that's going to be kind of the tutorial to really watch and get involved with. After that, we'll do an example of kind of a preview capability that we're working on for this quarter. with Chassis, which is exports out of cloud providers. Saumil's going to work with you to show you how we can go ahead and exfil a SageMaker, I want to say it's segmentation model, out of SageMaker into a container so that you can then use a model that you've trained on SageMaker anywhere, right? On your desktop, on cloud, on-prem, sort of take your pick. After that, I'll talk a little bit about enterprise deployments. We'll go over some roadmap items that we've got coming up in Q2, Q3, and then we'll do some QA type things if you've got any, and then kind of a little bonus gift thing that goes along with this. So with that, I'm going to go ahead and transition into kind of our pre-work review. So like I said, what we're going to do for this particular workshop is that you guys are going to get access to some Colab notebooks. We'll go ahead and we'll post the links into the chat here in a second to kind of get you moving and in that direction. But aside from the Colab notebooks, there are a few things that we'd like for you to spend some time with. The first is getting access to the Discord server. The Discord server link that you have here in front of you, and that this QR code that you see to the right also goes to, is actually to the Modzy server, which hosts the Chassis, channel that is largely used for communicating any information about Chassis. It's also where Saumil and I hang out the most and interact with users for Chassis. So if you have questions about how to use Chassis, or you get stuck along the way with something after this particular workshop, that's going to be the place where you'll be able to reach out and get access to the two of us, so that we can help work through any sort of problems that you happen to encounter. Now, for the first part of the hands-on stuff with the Colab notebooks, you're going to need a Google account. So if you got a Gmail account, you're good. It just so happens that Colab notebooks are run on Google servers, and Google doesn't want to give access to people that don't have accounts. So if you don't have like a Gmail account or a Google account, something like that, I encourage you to go set one up real quick. In addition to that, I know I'm telling you to go grab some stuff. I'm going to spend some time doing kind of like background on Chassis here in a minute, which will give you some time and opportunity to go download these without missing too much of the hands-on stuff. In addition to that, Chassis generally submits the containers that it builds off to Docker Hub for storage. So if you don't have a Docker Hub account, you're going to need that as well. And finally, you're going to need Chassis server access. Okay, Chassis has two parts. There's an SDK that sits locally, and then there's a service that your kind of local constructions get submitted to for actual processing. There are two ways to actually get access to a Chassis server. One is to follow the instructions on the Chassis.ml website to set up locally on a local Kubernetes cluster. But for this particular workshop, we've actually set up access to the free hosted version using the URL that you see here. So it's chassis-mlopsworld.modzy.com. You're going to need that as an endpoint in the notebooks that we're going to use here in a few minutes. But that will only work today and possibly tomorrow. Chassis.modzy.com, which we'll drop into the chat, is the place that you'll need to go in order to get access to the hosted Chassis service from probably tomorrow forward. Unless, of course, you want to install it locally on your machine using, say, the Kubernetes instance that comes along with Docker Desktop. There are actually instructions for that on the Chassis.ml website, so that you can do everything local or within your own corporate environment as well. So those things will get you access to be able to publish an ML model that you've built to Chassis. These last few things, Python 3 virtual environment, the Chassis SDK, and the Modzy SDK, those are all about being able to interact with models that have been built via Chassis. And so these are all, when I say models, they're actually all about being able to interact with the containers that have been created from models via Chassis. And so if you're going to want to interact with them locally and follow along with Saumil, you're going to need to have access to at least the Chassis SDK. And the final is Docker installed locally. I know it seems a little silly that I'm telling you to get Docker stuff on a talk where we're focused on generating containers, but just to be thorough, you're going to need Docker sitting locally on your machine in order to be able to pull down the containers from Docker Hub that we're going to make, or that Chassis is going to make behind the scenes for you, and to be able to experiment with them locally. All right. And so I know I asked you to get a couple of accounts here to set up a virtual environment or two. Saumil looks like he dropped basically all the links into the chat. And so I'm going to take a couple of minutes. I'm going to tell us a little bit about Chassis' background, where it came from, what it's supposed to be doing. And if you haven't had the time to join the Discord server or set up those accounts, that would probably be a really good time to do it before we get involved with the actual notebooks themselves. All right, so a little bit of background for Chassis, right? Over the last, I would say, decade or so, there has been a huge amount of AI investments by several organizations, including a lot of the ones that employ you guys, right? And those investments have been both in infrastructure as well as a data scientist or two, or a whole team of data scientists, right? And as corporations have dumped more money at AI and ML as a solution space, eventually what they want is the data scientists to build models of some sort that has an ROI that they can articulate back to sort of justify the investment that they've made from a corporate standpoint. Even if you're doing it for research, you have to be able to show, some sort of capability or some sort of academic publishing, something along those lines, right? People want to see some sort of ROI associated with their investment. And so after the data science teams typically have been incredibly prolific in building models, there's usually a meeting with a manager or an administrator or someone like that that says, hey, what are we actually getting for all of this investment, right? And the data science team will tell them about the great models that have been built and how those models have accuracies of 99% or F1 scores in the high 90s, or how they can increase foot traffic 20% in their stores, for example, those sorts of things. At which point the manager says, that's great, let's go ahead and use this, right? And the data science team, the whole time, they've been building models, they've been trying to do things they thought would be useful, and they are convinced they've got something new. So they say, great, we'll go ahead and we'll deploy that. Who do we need to talk to? And the manager will say, go talk to my IT team or go talk to my DevOps team. And so meetings get set up, data science and DevOps talk. DevOps decides, yeah, that's great. We'll go ahead. We'll publish a model. Just hand it to us. And the data science team inevitably tosses them some sort of pickle file or PyTorch file or something like that. And the data science and the DevOps team just kind of looks at them and says, what is that? Right? It's a file. At the end of the day, everything that comes out of AI and ML model training tools or frameworks or paradigms, they're files that are not necessarily executable. They're not executable. They have dependency lists. There are a lot of things that you have to do to a model to turn it into an executable that can work in any sort of environment, right? And so the DevOps team looks at data science team and says, hey, we either need an executable or we need a Docker container. Those are the two things that can really run on our IT systems. And those are really the things that we can deploy. Until you can do that, we can't publish any of your models to our corporate infrastructure or the enterprise IT in general, which is usually fairly disheartening for the data science team. And so they go back, they look through all the models that they've built, and they try to identify one most of the time. And they try then to take that one model and shepherd it into some sort of executable that can then be put up on the IT infrastructure somewhere. Now, this process is long. You think this animation is taking a bit. Gartner tells us this usually takes about 9 months, and half of all journeys of models from data science teams to DevOps teams fail. Okay, that is the area that is really the thing that spawned Chassis. This need to be able to take models that are generated on the data science teams or by the data science teams and provide them to DevOps teams or to IT administrators quickly and robustly. We saw that as kind of an opening and a place that the MLOps pipelines were really lacking in terms of just smooth capabilities. And so we built Chassis to go ahead and kind of fill that void between the data science and the DevOps teams, to take in models that are generated by generally available and used different training frameworks, and to turn all of them into Docker containers automatically, so that the data science teams could take their models, turn them into Docker containers, and not have to know anything like DevOps principles, right? Not have to understand Docker. Only use a few lines of code and a couple of imports along the way. And so that's what we built with Chassis. That's what we're going to use to show you how to automatically containerize your ML models. And we are going to start that right now as I transition this off to Saumil.
Great, thanks, Clayton. Let me go ahead and share my window. All right. So the first thing I'm going to do is post our repo link, the Chassis repo link in the chat. And the next thing is I will ask you guys all to go to collab.research.google.com. If you guys were able to follow the pre-work, you will be able to follow along with these examples. And if you have signed in to your Google account, then this should pop up. And the really nice thing about Colab, well, first of all, if you're not familiar with Colab, it's very similar to Jupyter Notebooks if you've used those, but they're hosted on Google's infrastructure. And they have this really nice functionality for you to be able to put in a repo. So we'll go ahead and copy paste that Chassis repo link into this field right here, hit enter, and it'll find all the notebooks within that repo. So we've prepared several notebooks for today's talk. They're in this Colab Notebooks branch, so go ahead and switch to that. And the first one we're going to work with is the fourth one in this list, sklearn, or Colab Quick Starts, sklearn SVM image classification. So go ahead and click that. All right, and throughout these examples, if you have any questions as you're following along or run into issues, please feel free to drop a question in the chat, and Clayton will be happy to help you out. Okay. So let's go ahead and start walking through this. You can run these cells by hitting Shift Return, Shift Enter, or just hitting the play button. So in this notebook, we are going to be containerizing a scikit-learn model through Chassis. And the first thing that we need to do is install our Chassis SDK using a simple pip install, which we're going to do up here. So let me go ahead and kick that off. You'll get a warning that says this was not authored by Google. It was authored by us. We have not inserted any malicious code, so don't worry about that. Go ahead and click run anyway. And you'll see these two additional weird looking lines here. The reason for that is when you open up a Colab notebook, there's already a pre-configured environment. And when you install the Chassis.ml SDK, we may be overwriting certain versions of already existing packages. And as you'll see later on in this notebook, we're going to have Chassis go ahead using MLflow under the hood and infer all of the dependencies required to run your model. And we found that if we make modifications like this without killing the Google Colab runtime, that actually causes issues during that inferring of those dependencies. All right, so you'll see this warning at the bottom. That's actually fine. That's expected. All we're doing is restarting the runtime fresh with that Chassis SDK installed. Next thing we'll do is we'll go ahead and do some imports. So we'll see our Chassis SDK, a couple of other things that we'll use in different ways. And as I mentioned, we're going to be working with a scikit-learn SVM model. All right, so as we mentioned previously, or as Clayton mentioned rather, you do need a Docker Hub account in order to follow along with these examples, because Chassis will be pushing these model images to Docker Hub. So go ahead and enter your username and password. Okay, so the next piece, we're going to go ahead and train a model. This will be a digits classifier. I assume many of you are familiar with the classic digits data set, basically classifying handwritten digits. And we don't need to worry too much about this piece. Again, Chassis is more concerned with making it super easy to containerize your model, so we're not going to worry about optimizing metrics against this data set or anything like that. But we do need to have a model to work with, so we will load the digits data set. This is available directly through the scikit-learn datasets subpackage. We'll do some pre-processing. We'll go ahead and, again, through scikit-learn, load our support vector classifier. We will split the data set up, and we are going to train the model. Okay, so now we've got our model. It's called CLF. And now is arguably the most important part in the process. we need to actually tell Chassis what to do with this model. So the way that we do that is by using this required process function. Now, process function you can always expect inputs in the form of bytes. We've chosen to do that to keep things general. So any file can be loaded in as bytes. It can be text, audio, video, whatever the case. In this case, we will expect an input that looks like this. There are several entries in here that we expect to be classified. You'll notice that we haven't done any error handling here. That doesn't mean it's not a good idea to do so. We just wanted to keep things simple for this demo. So if you wanted to validate that these bytes are actually the input format that you are expecting and raise an exception if that's not the case, you can absolutely do so. But again, we haven't done that here just to keep things simple. So this function is actually responsible for doing everything that is required to go from those input bytes that your model container will be receiving for an inference call all the way through to formatted inference results. So that includes any pre-processing required prior to submitting that input to your model. Also, any post-processing that's required to go from that those model outputs to a nicely formatted output that we'd eventually like the model container to return to the user. So as I step through this, first thing we're going to do is we're going to load in those bytes using the JSON package, convert that to a NumPy array so that we can submit it to our model. And let's say that our pre-processing step that's required is just to divide by 2. Just a simple example, but just to sort of demonstrate pre-processing, inference, and post-processing. So once we've done our pre-processing step here, we can go ahead and submit that input to our model. Now, the really nice thing about Chassis is that anything that's been loaded into memory previously can be leveraged within this process function. And so you'll remember that we did actually just train the classifier. It is loaded into memory. We can just go ahead and use it in this process function, and Chassis under the hood will handle serializing things out in a bit, but I will get to that. Okay, so we've defined our process function telling Chassis what to do. Now, as Clayton mentioned, we have set up a temporary sort of endpoint for our hosted Chassis service. I'm going to go ahead and copy over that link so that we can point to our hosted Chassis service. Again, this will only be available today and possibly tomorrow, but if you'd like to use this free service longer term, please go ahead and click this link, sign up. This link is actually chassis.modzy.com, and you can sign up there. You'll receive an email with a unique endpoint that you can leverage moving forward. But again, we're going to use this one for now, and this is the first time that we're actually using our Chassis SDK. The first thing that we're going to do is initialize our Chassis client, which will be communicating with this hosted Chassis service, and we just need to point to that endpoint. Now, once we've got our Chassis client initialized, we can go ahead and call its create model method, and all we need to do is pass that process function that we defined above. And then the next piece we're going to do in this cell is to download that input sample file. This is sort of the quickest way for us to get this input file onto the server that's running this Colab notebook so that it can be accessed from this notebook. So we'll just load it in, we'll save it out as input sample.json in this same directory. And then we can call the chassis model.test functionality to test things locally prior to submitting a full-on model image build job. So this will test things here. The nice thing about this is you can pass a file path, a Python buffer reader, bytes, or text, and Chassis will figure out what to do with it. In this case, we're going to go ahead and pass that sample file path. And it looks like things are working as expected locally. We do get our nicely formatted results as we expect. Now, one thing that I didn't mention above that I do want to make sure to mention is that the only requirement for your output is that it is JSON serializable. So anything that's not JSON serializable automatically will throw an error when you go ahead and try to run that test job, with the exception of NumPy arrays. We've actually included support within the Chassis SDK using a custom encoder for you to be able to serialize that data out. Okay, now that things are working as expected, what we can do is go ahead and kick off our actual Chassis job by calling the Chassis models publish method. And all we need to do is provide these 4 required arguments. These are the model name, your desired model name, a desired model version, and then these Docker Hub credentials that we defined earlier. What that's going to do under the hood is it's going to serialize out your model. It's going to save out your model. It is also going to infer, as I mentioned earlier, all of the dependencies that are required to run your model. And it's going to save that along with this information that you've provided here into a nice archive. It'll submit that over to our hosted chassis service that we pointed to up here. And then if the job was successfully submitted, which it looks like it was once we received this OK message, it'll return in the response a job ID. And that job ID can be used with Chassis client's block until complete method, which does exactly what it sounds like. It will keep pinging the service with that job ID saying, hey, are you done yet, until it receives a completed status. And at that point, our model image will be sitting in our Docker Hub account and ready to use. So while that's building, this will take a few minutes. I'm going to hand it back over to Clayton to talk a little bit more about what's happening under the hood.
All right, I am going to go ahead and reshare. All right, so I'm going to talk a little bit under the hood. While we do that, Saumil, I think there's some questions about Python dependencies in the chat, if you want to take a swing at that. So under the hood, what happens is that, like I said earlier, Chassis comes in two parts. There's a local part that's basically focused on the SDK, and then there's a service part we'll see here in just a second. And whether you use straight Python or a Jupyter notebook or a Colab notebook, what have you, the process is generally the same. You have a model of some sort, and in our case, we actually built that model, but it could be a model that you've previously built under some other paradigm, and you take that model, you load it in to into your code, right? The Chassis SDK then looks at your model along with that process function that you created and wraps your model in this in what we call the chassis model sitting there in the Jupyter notebook. And the chassis model is a templated thing for us. We know and utilize the fact that the chassis model is always going to have a process function, and that's how it's going to interact with your model to ensure that we can actually access your model and that we can run the tests that sit in the notebook, for example. So what you'll do is you create your model, you create that chassis model, and then in order to actually submit the model for containerization, there are certain things that we need to make sure the chassis service has access to. And we're going to go ahead and we're going to package those up. The base items that we need to make sure that the chassis service has access to were the four things that we provided to the publish method, right? The name that you want to associate with the container, the tag you want to associate with the container in terms of version, and then your Docker credentials, both your username as well as your password. Okay. Once the Chassis SDK locally has all of that, the publish method wraps everything in an HTTP request. All right. And you should bear in mind that these requests can get kind of large because we are essentially going to serialize your entire model, and then we're going to ship that off to the chassis service itself for the further processing. So normally this process is pretty simple with, say, an sklearn model, but you're going to see an example in a minute that's actually going to use a PyTorch model, deep learning model as part of this, as part of our examples here. So locally, we build that HTTP request, and then using the endpoint for the server, which for today is that chassis-mlopsworld.modzy.com for those that are using a hosted service. For those who have the Chassis API server installed locally that have followed the Chassis.ml local installation instructions, it's going to be localhost 5000 by default. I think that's what the service listens to. Or by default, that's how we normally set it up with the Kubernetes cluster. So it's localhost wherever you've got the Kubernetes cluster listening. The publish method, after it finishes wrapping up the HTTP request, it submits it on over to the server. And then on the server side, your model is pulled apart again, okay, from the data inside the request. And it reconstructs your model wrapped inside of that chassis model, okay? Then what it does is it wraps it further in one additional model, okay? And that additional model adds additional functionality that we expect for all models to have just kind of in general in the wild. All right. And it'll be the last sort of layer of the onion for your model and the actual AI ML kind of implementation, kind of AI ML sort of responsibilities inside of the container. And so each of these models add just a little bit to the final product. Your model provides prediction capability. The chassis model provides pre-processing, post-processing sort of capabilities, as well as giving standard locations and names to the class that is then used by the container model and its final wrapping, which not only has access now to the pre-processing, post-processing, your model and all that, but it also takes care of things like making sure there's a default way to handle batch jobs when multiple inputs are submitted to your model in the container, making sure that you've got appropriate access to GPUs and interacting with the underlying CUDA environment if you've selected GPU as one of the things that you want available in your container. And so it's basically a utility model that we're sitting on top to make interactions with the chassis model easier. Once that particular model has been built and we have something that we can interact with singly or batch and is ready for whatever environment we plan on deploying to, then there will be one final wrapping that happens with a gRPC server. Now, all interactions with a chassis model from outside the container are going to take place over a gRPC connection. Saumil is going to show you some examples of communicating with the server, both locally sitting on your machine using code that's just straight up Python code from the Chassis SDK. And he's also going to show you an example of how you can interact with one of these containers using a no-code approach with Postman here in a couple of minutes. But the bottom line is that these are kind of the total layers that get added on top of your model inside of Chassis on your service, or when the Chassis service gets a hold of that HTTP request. Once that's been built, right, inside of Chassis service, we leverage a piece of software called Canico. Canico, if you're not familiar with it, it's a Google open source project, and its basic job is to build Docker containers inside of a Docker container. And to do it in a secure way that doesn't expose things like the Docker socket sitting inside of the kernel. And so Canico will then take all of the gRPC wrapped models, it will convert it to a Docker container, and then using the Docker credentials that you provided as part of that package data, we'll ship it on out and over to Docker Hub, where your container is then available for you or anyone you've given access to your repo to then download and use anywhere that a Docker daemon can actually run. The Docker daemon or a container D, the containers that are built are OCI compliant. So they will run on your desktop, they will run in the cloud. We've even built some and run them on IoT devices like Raspberry Pis and Jetson Nanos, doing doing computer vision sort of applications. And so that's most of what's going on underneath the hood for Chassis. And so I think now I'm going to hand it back on over to Saumil and on over to Saumil and let him walk you through downloading the models and interacting with them locally.
Cool, thanks, Clayton. Let me share again. All right, so while Clayton was explaining what's happening under the hood, looks like our job completed. If I go over to my Docker Hub account, it does look like 3 minutes ago there was a new image pushed. And so what we can do is go ahead and test this locally with the Chassis SDK, locally meaning on my laptop. So I mentioned a couple things in the chat. If you have Docker running, if you are able to clone the repo, in the root directory of the repo is this test.py script. Right, and if you've got the Chassis.ml SDK loaded into your environment, installed into your environment, you should be able to run this if you've been following along. All you need to do is replace this image ID with yours. So you can go ahead and pull the image name and tag from your Docker Hub and copy that in here. I've done so and copied that into this Jupyter notebook that I've got running locally on my machine. And I want to point out a couple of other arguments. So the host port, you can specify whatever you want as long as there isn't another process that's using that particular port on your machine. What that's doing is inside the actual model container that Chassis just built, the model server will be running on port 45,000. We need to map that out to the host machine on some port so that we can access it from the host machine. Here, cleanup equals true means it'll kill the container once it's done with this sample job that we're about to run. And pull container equals true means if that image is not, doesn't exist in your local Docker registry, it'll go ahead and pull it down for you. So we can go ahead and pull this. This data that's in the script is actually compatible with this model. And it looks like we are already getting some results, which is good. So again, this I had this image pulled down previously. That's why it went super fast. It might take a little bit longer for you to actually pull that image. But it pulled the image down, spun it up, exposed port 5002 on the host machine, and it made a request with this sample input data. And we got back the results. And it looks like things are working as expected with our newly created chassis model, which is pretty cool. All right, so now let's move on to a slightly more sophisticated example using PyTorch. So what we can do is go back to collab.research.google.com. We will follow similar steps to what we did in the previous example, specifically going to the GitHub tab, copying over the chassis repo link. That's not it. All right, and don't forget to switch to the Collab Notebooks branch. And this time we are going to select the second one, PyTorch ResNet 50 image classification. All right, so again, installing our Chassis SDK and then restarting the runtime, just as we did previously to avoid issues when MLflow tries to infer dependencies. We'll give it a couple seconds. I'll take a sip of water. All right, cool. Looks like things have installed. Runtime has restarted. And so here we'll do our imports again, but this time you'll see some new additions. As I mentioned, we're going to be working with a PyTorch model here. So you see Torch, Torch Vision, etc. Again, we need to provide our Docker Hub credentials. All right, so here's where things start to differ. In the previous example, the only thing that we needed to leverage from outside of that process function was the model itself that we had trained. But what if you have a use case in which you need additional pieces of data in order to perform your full inference? So for example, here we've got this labels file. What this is doing is mapping output class indices of your model to human readable labels. So if the model outputs class 3 as its top prediction, what does that actually mean? Well, if you want the user of your model container to actually know, then you need to be able to map that to a human readable label. So we're mapping those from the ImageNet dataset. Up here, we're actually just going to use one of PyTorch's pre-trained ResNet 50 architecture models pre-trained on the ImageNet dataset. So that's super easy to load in by just passing this pre-trained equals true argument. And you know, for now we're using a pre-trained model, but you can imagine this could be your own PyTorch model. You could have defined some custom architecture and trained on your own data set. As long as you're able to load it in here, you can use it. If you're familiar with PyTorch, we set it to eval mode, which is just inference mode. So there's no backpropagation or weight updates. And again, if you're familiar with PyTorch, these two pieces, the transform is available through Torch Vision for computer vision use cases. It tells PyTorch how you want to pre-process your image prior to submitting it to your model. So we'll just do some resizing, convert it to a Torch tensor, and do some normalization, and then we'll go ahead and submit it to the model. And also, in PyTorch, you need to specify your device. So you can do CPU if you want to use CUDA, or if you want to use GPU, you specify this as CUDA, and I'm about to show you an example of that in a second in the next notebook. But for now, we're just going to run things on CPU. So let's go ahead and run this. Downloaded the pre-trained weights, pulled the labels, looks like everything was loaded into memory, which means that we can then use it in our process function. So if you'll remember, this process function takes bytes. It's responsible for pre-processing, inference, post-processing, and returning a final result. So in this case, we've actually, this is an image classification model, so we are going to expect images. Again, if you want to do some input validation and raise exceptions, if invalid data has been provided, you can do so here, but we haven't, to keep things simple. You can use CV2 IMD code. CV2 OpenCV is OpenCV. It's a popular computer vision package. And we'll use that to get to a NumPy array, a representation of the pixel values of the input image that we're receiving. Then we can run our transform. So again, we defined our transformation steps above here. We can use it in our process function. And then we will call unsqueeze. Don't worry too much about that. If you're not familiar with PyTorch, it's essentially adding an extra dimension to the tensor so that it can be submitted to the model. Again, this talk isn't too much about the details of the models. It's more about easily containerizing them. So we move that over to the device. This is more important if you're using GPU, which again, I'm going to show you an example of. But now we've got our pre-processed input image tensor that we can then directly submit to our model that we loaded in above. We'll then do our post-processing steps. So we'll run a softmax normalization. Again, don't worry if you're not familiar with that. And we're basically just going to take the top 5 predictions, grab their human readable class labels, grab their scores, create this nice little output structure that we eventually want to return to users that are submitting inference jobs. Okay, so now that we've defined that, again, we're going to go ahead and copy over our chassis, hosted chassis URL. We will initialize our chassis client. And just like we've done before, things should kind of start to look familiar here. We're going to create our model by passing our process function that we defined above. We're going to pull, this time, an image of an airplane that we've got sitting in the repo, and we'll save that out to a local file, and then we'll use that chassis model.test functionality pointing to that sample file path and make sure things are working as expected, and it looks like they are. This image of an airplane was classified as an airliner, 92% score. So now that things are working, again, locally, we're ready to call chassis model.publish. So we need to provide 4 arguments to that publish method: model name, model version, Docker Hub credentials. And again, this will serialize the model out. It will infer the dependencies. It will package all of that up along with these arguments and send it to the chassis service, which will then kick off our image build job. And that will again result in a new image sitting in our Docker Hub. All right, so this will take a few minutes to run again. So I want to jump over to the GPU version of this notebook. So we will follow some of the same steps to get started. Copy this over. And this time we're going to select the third one. It should have batch GPU appended to the end of the notebook name. Okay, so first thing we want to do, go to runtime, change runtime type. And the really nice thing about Colab is that it does provide GPU access, and it's super easy, just like this. All right, so let's say, in the previous 2 examples, we've basically taken a single input and processed a single input at a time, and we've only run the models on CPU. But what if for performance purposes, you'd like to leverage batch inference and you'd like to actually leverage GPU access? This is especially important for deep learning applications, which can be computationally intensive. Well, Chassis actually got support for that as well. And that's what I'd like to demonstrate here. So we'll follow some similar steps. A lot of the pieces of this notebook are exactly the same as the previous notebook, and so I'm not going to go too much into detail or as much into detail as I did, but I will point out where things kind of start to differ. So give it a sec to install that Chassis SDK. Looks like it's done. Run our imports. And this time we're not actually going to kick off the build. So we don't need to enter our Docker Hub credentials. But everything looks the same up to this point. And then here's where things start to differ for the first time. As I mentioned in PyTorch, if you specify your device as CUDA, the string CUDA, and then you call model.toDevice, it'll actually go ahead and move that model over to the GPU, provided that you have GPU access. It is actually a good idea to check if CUDA access is, or if GPU access is available, and if not, fall back to CPU. But here, since we want to keep the two examples explicitly separate, we're just going to specify it as CUDA. All right, looks like things worked because it printed out this model summary. So here is, in my opinion, the main way things differ if you'd like to leverage batch inference. So previously, you'll remember we defined this process function, and it took a single input in the form of bytes. Now, if we want to do batch inference, we can expect that this function is going to receive a list of inputs in the form of bytes, and we're then responsible for pre-processing all of them. So here what we do, we run our IMD code as we did before, as we're looping through those inputs, but then we concatenate them into a single torch tensor. And then we submit that single torch tensor to the model at once. That's how you get that performance increase. And after that, we're going to pull the data back, or the outputs off that GPU, convert to a NumPy array, and post-process all of those results, and append all of those post-processed formatted results to this list that we're eventually going to return to the user. And it's important to mention that you do need to maintain the order. So the order in which the inputs are received is the order, must correspond to the order in which the formatted results are outputted to the user. Okay, so you receive a list and you output a list of formatted results. Again, we're not going to build this one, so we don't need to worry about this argument connecting to that chassis service. But here's the next place where things differ. So previously, the argument was called process function because we were providing only a single input process function. Now what we need to do is provide a batch process function and point to that function that we defined above. And if you do provide that batch process function, you are required to provide a batch size so that the model container knows how many inputs it can accept at once. Again, we'll pull down our sample input file and run test locally. So one of the other really nice things is that you're only required to define one of the two being the single input process function and the batch process function. And Chassis under the hood will handle each of those scenarios. More specifically, if a batch of inputs is sent to the model container, but only the single input process function has been defined, it will process each of those inputs independently and send back the batch of results. And vice versa, if the batch process function is the only thing that you've provided, but only a single input comes in, that will be handled as well here under the hood for you. So you don't need to worry about providing both. Although if you do want separate behavior in each of those scenarios, you can provide both functions. Okay, so it looks like the single input case worked locally. Now we've also got this test batch functionality, which will basically, we still provide only a single input file path, but what it's going to do under the hood is go ahead and repeat that input batch size number of times and send that over to the model. And now we've got our batch of results. It looks like there are a bunch of results here. There should be 8. I'm not going to count them. And And what we can do here is run NVIDIA SMI tool to make sure that the GPU is being used. And the fact that there is some memory usage here means that model is actually on that GPU. All right, so the last place where things sort of differ here is you need to provide this simple GPU equals true argument that will tell the chassis service to use a base image that's got CUDA toolkit, everything else required actually installed. And that's really it. The resulting image will actually be able to leverage GPU if you followed all of these steps, and it'll also be able to run batch inference. Obviously, provided that the host machine to which you're the machine to which you're deploying your model container actually does have GPU access. Okay, so it looks like this build is still going on. So I'm going to move on to the next example, and we will circle back around to this. All right. So as Clayton mentioned earlier, we're going to talk a little bit about PMML. So this will be sort of the last hands-on example that you can follow along with. The point we kind of like to make here is that, let's say you've trained a model using some external platform, RapidMiner, Dataiku. A lot of these products support sort of this common output format called PMML, which is relatively old but popular for data mining, sort of statistical models. It's sort of a language that several different products can speak. But if you've trained a model using one of those platforms, but you'd like sort of this standalone containerized version of the model that you can deploy in different places, Chassis got support for that as well. So what we're going to do is install our Chassis SDK, but then also this additional dependency here that will allow us to load in that exported PMML model. So it looks like things are installing here. Give it a second to complete. This model is going to be a classification model using the popular iris dataset. If you're not familiar, it's a tabular dataset, and the task is to classify 3 different types of the iris plant. So we'll import everything that we need, including that additional package that we installed. We will input our credentials. All right, so again, just like the digits data set, we are actually going to go ahead and load the iris data set directly from scikit-learn.datasets. And we'll convert that to a data frame, do a little bit of formatting. We'll split the data up, and we're going to actually save out some sample data that we're going to use as our sample input file, as we've done a few times in the past. Okay. So here we've got this random forest model. Let's say that we've trained this using one of those other external products, and that product allowed us to export it in PMML format. Well, we've got one of these examples sitting in our repo, so we'll go ahead and download that down to a location where this Colab notebook can access. So we'll just save it to the same directory. And we'll use that additional package that we installed to be able to load that model in. This format actually allows you to embed the list of classes into that actual PMML file, so we'll load those out as well. And we'll run a sample inference, and this means that things are working as expected. So in the previous examples, we included all of the pre-processing, post-processing steps within that single function. Maybe you want to logically separate things out, which you can certainly do. And so that's what we've done here. We have our pre-process function here that'll take those raw bytes and output a pandas data frame. And then we've got our post-processing function that will run after inference that will take those raw model outputs and then create our nice human-readable structure and output that to the user. So we'll define those. And now because we've split those out, our process function is actually nice and simple. Only these 3 lines. Pre-processing, running inference, post-processing those raw outputs, I guess 4 lines, returning them to the user. All right, so I need that endpoint. to be copied over so that we can actually kick off an image build. Initialize our chassis client, create our model using that process function that we defined above, and we will pass that sample data that we saved out above as well to the model. And it looks like we've got our predictions here. Things are looking good. We can then go ahead and, as we have a few times now, kick off our chassis job. So to kind of reiterate the purpose of this example, if you are using different training products, and maybe they have their own deployment options, maybe they don't, but you'd like a little bit more flexibility as far as where you're going to deploy your model into production, Chassis got support as long as you're able to load that model in and write some inference code to be able to containerize that for you and give you a model container with all the required dependencies in there that you can run anywhere. All right, so while I was doing that, I believe this completed. So we'll go over to my Docker Hub, make sure that the new image is in there. Oops. All right, looks like it was 4 minutes ago. So this model is a little bit bigger, but I am going to run it locally. So let me go over to this tab. So I've got this image resulting from a previous run. I basically did the exact same thing with that PyTorch Resident 50 model, ran it through Chassis. I don't want to do a Docker pull because if something changed, it could take a little bit. And my Docker pulls have been pretty slow recently, so I don't want you guys to just sit here and watch that. So I've got this example image pulled down, running from a previous Chassis run, and I'm just going to run it manually using a Docker run command. And this port mapping, as I mentioned before, the model server within the container is listening on port 45,000. We do need to map that out to the host machine so that we can access it. So that's all I'm doing here. And it looks like our server is spun up and running. So Clayton mentioned Postman earlier. It's a really helpful tool in building APIs, testing APIs, and it allows us to make gRPC requests, which is super helpful for us. So what we can do is go to new, create a gRPC request. We can put in we can point to our running model container that just came out of Chassis. And there are a few ways to load, to basically tell Postman how to interact with this model. So the really cool thing about gRPC, if something called server reflection has been implemented, which it has in Chassis, you can basically just hit that button and it'll it'll essentially automatically return the information required for the client to understand how to communicate, what routes are available, all of those things with that model container. Another way that you can do it is to explicitly point to a proto file in gRPC, which again defines the API that a service exposes. And that's what the option that we're going to choose today. And so kind of hard to get to. We'd like to make this more prominent, but what happened? Oh, there it is. That proto file is available within the Chassis repo. Again, defining that gRPC API, routes available, inputs and output, structures, all of those sorts of things. And so what I've done is downloaded that locally. Clayton, could you, or actually I can just go ahead and drop it in the chat real quick. So I've downloaded that locally, and what we can do is point to that proto file. So I've already got this loaded, and hit next. We provide a name. We'll just call this Chassis demo, give it a version. And just like that, it should understand how it needs to communicate with that model container. So as you see, 3 routes have populated: status, run, and shutdown. Those are the routes exposed by our service, our model service. Okay, so first thing we need to do is call status.
Hey, Saumil, I don't mean to interrupt you, but we're actually seeing the browser and not Postman.
Oh, sorry about that. Let me run those steps back. I think that's my fault because I shared only the window. Okay, so my apologies again, but I'll just quickly recap what I've done. I've pulled a model image resulting from a previous chassis run down. I've done a manual Docker run command, and I have done this port mapping so that we can access the port via localhost. Then I went over to Postman, which is a tool that's helpful in testing APIs, allows us to make gRPC requests. And I've pulled down that proto file defining the gRPC API. This will allow Postman to understand how it needs to communicate with our model container. I'm going to point to that proto file that I've pulled down locally. I will hit next, provide a name, a version. Okay. Not sure why that, maybe it didn't like that I repeated the same thing. So let me go back to the previous example. So I basically followed those exact same steps and got to this point. So what we do is first we hit that status route. What that does is tells the model container to initialize the model, and it also returns some nice metadata, input, output information, timeout values, etc. And then the next thing we can do is hit the run route that is exposed by that model container. So this structure might look a little weird and repetitive. There is more information on the Chassis.ml site on how to structure that input. So if you go to Chassis.ml, all that information is there. But I've copied that down here, and what we need to do is embed a base64 encoded image into this request body. So I've already done that here. This is another image of an airplane. And what we can do is go ahead and hit run once I've generated that body. And looks like we've got a 200 response, which means inference was successfully executed against that model container. And we've got base64 encoded results. So we can copy that, go over to the terminal, and we'll use pb paste, basically just pulls whatever's in the clipboard, passes it to base64 decode. And looks like once decoded, the results look as we expect them to. So we've got our inference results. This was classified as an airliner correctly. So this isn't the way that you would run things in production, but just another way to sort of test your model container and communicate with the model container, and hopefully help you get an understanding of the routes that it exposes once it's built. Okay. So the next thing that I'd like to show is some functionality that is coming soon, but not yet available. So you won't be able to run this example. Let me switch back to sharing my window. Okay. So sort of along the same lines as the PMML example, let's say you've trained a model using some external platform. Maybe it has its own deployment option and maybe it doesn't. But again, if you'd like more flexibility and you'd like a model container that can be deployed in other places, Chassis can support that as well. So we've got support coming soon, integrations with SageMaker, a subset of their built-in algorithms, Azure ML, and also MLflow. So if you've registered models to MLflow, we can pull them down and containerize them as well. All right, so we are going to walk through a SageMaker semantic segmentation example real quick. So basically, semantic segmentation, if you're not familiar with it, is a computer vision task, and you're trying to classify every single pixel within an input image, right? So does this pixel belong to the background? Is it part of a motorcycle, a person, etc.? So I'm not going to go too deep into this notebook. This is SageMaker's example semantic segmentation training example notebook. And basically this is trained on the Pascal VOC dataset. All the classes are listed here. And this basically defines how you can sort of configure a training job and kick it off. So once this fit call is completed, the output of that SageMaker training job is an weights archive that's sitting in S3. So you can, as you can see here, deploy in SageMaker, but if you would like to export and deploy elsewhere, all you need to do is programmatically access the location, which you can do pretty easily, of those model weights that were put into S3. resulting from that training job. And then you've got everything you need to convert to that chassis model that we've been working with. So the first thing that you can do is optionally provide these labels. If you provide them, we will include them in the chassis model container output response, so that people who see the output mask that I'm going to show you can convert those class values to human readable labels. Then you need to point to those output model weights that are sitting in S3 resulting from that training job. So here's the bucket and key corresponding with those weights. You also need to tell Chassis what the model type is. In this case, it's semantic segmentation. Here I've loaded my Docker Hub credentials, and my S3 credentials are also required in this case so that we're able to pull down those model weights. Next thing we do is initialize our Chassis client. And here is where sort of the magic happens. So we've got this new create model from SageMaker functionality. We just provide our credentials and everything else we've defined above, pointing to those model weights, telling Chassis what the model type is. And that will, under the hood, convert to something that Chassis can run locally. We can then submit a file, just as we've done in the past with that local test functionality. So we'll submit this motorcycle image. And as you can see, here are the segmentation results. Sorry about the contrast, but this piece here at the top and the sort of motorcycle outline are actually different colors. So if you take a look at the output mask, this is what it looks like. It's a class value corresponding to every pixel location within the image. And we see some 15s, we see some 14s. And that's what I was talking about earlier. So we can have those labels that we use that class mapping to be able to convert from those class indices to human readable labels. So labels, class 14 is a motorbike and class 15 is a person, which is good because those are the two objects we would expect to have been recognized. Okay, and then after that point, what you can do is call chassis model.publish, just like we have with all of these other examples that we've shown previously. And that will essentially containerize your model in the same way that we've done with the other models. So just sort of another example and some new functionality coming soon for you to be able to export models that have been trained elsewhere in popular sort of, maybe cloud provider machine learning platforms, and get a sort of standalone container that can be deployed in a variety of locations. All right. So I think that concludes the set of examples that I wanted to show. And I am now going to pass it back over to Clayton to talk more about, sort of different places and different platforms to which the resulting chassis model containers can be deployed. Thank you all for your time.
Thanks a lot, Saumil. There's one question about the models in the chat if you want to take a swing at it. I know the S3 has been your baby here for the last few months. I am going to pull back up my screen share. And, all right, cool. All right, guys. So you spent roughly the last hour listening to me talk about Chassis and walking with Saumil through several sort of Chassis publishments to containerize models that we've kind of built in notebooks, and you've seen him pull those down, work with them locally through code and no code sort of situations. But Chassis was actually built and engineered to design the problem of organizations who have data science teams that want to get models out of their lab and off into production, right, quickly and in a way that the DevOps team can use it. And so it really flourishes under the idea of being used for the enterprise. And so Chassis itself has been built to make sure that we enable that kind of out of the box. Chassis is an implementation of the Open Model Interface or Open Model Initiative. For those of you who've never seen that before, you can take a look at openmodel.ml. But the bottom line is that all the containers that come out of Chassis, in addition to being able to run by themselves on your desktop or in the cloud or on your IoT devices, they're also already compatible with enterprise deployments on Modzy. I'm sure that's a big surprise, and Kserve. So that was really the goal when we built Chassis, was to be able to provide that bridge, not just for these one-off sort of things that you can put in different places, but to be able to provide models that have value to the enterprise when you need to be able to provide a model that can be accessed by not just one or two people, but scaling horizontally and all that nice fun stuff. If you want to try to do that and really kind of get the full value out of Chassis, there's a lot of documentation on our website that'll walk you through how to ingest your model either into Modzy or into Kserve. If you go ahead and try that and you run into problems along the way, feel free, of course, to reach out to us in the Discord, in the Discord server that we posted the link to here a little earlier. I'm sure we'll post it again here in a second. Saumil and I hang out there pretty regularly. And so we'll be happy to help walk you through any problems you encounter deploying either to Modzy or to Kserve just in general. Okay. Roadmap. I know some of you have been asking about different capabilities over in the side. These are the things that we have that we're going to be focusing on Q2 and Q3. And I think I'm going to start co-opting one or two of these other things I see over here, maybe for Q4. But kind of on the horizon for this quarter, you just saw Saumil run Chassis and pull a model that was built in SageMaker out into a container that can now run either on the cloud or on-prem, kind of anywhere you want. So that'll be rolling out here at the end of Q2. We've had a user that that's tried to install Chassis back behind a pretty significant corporate set of firewalls and has reached out to us for proxy support. And so literally as soon as this conference is over, Saumil and I have a whiteboard full of ideas for figuring out proxy support. So that's going to be our next big push here in Q2. And then in Q3, we're going to try to get at least some limited automatic explainability into the containers. And so we haven't really quite figured out what the exact footprint is going to be yet for frameworks that we're going to offer it for. But the basic idea is going to be if you're doing something simple, right, like an sklearn style model that will go ahead and infer that and then automatically hook you up with something like Lime, while also providing you the ability to override that if you have some other kind of special or proprietary explainability that you're going to want to add in to the container. So we're just trying to give easy buttons really to a lot of the ML sort of stuff. And the last thing for Q3, ecosystem support. You know, Saumil's walked you through examples of sklearn, PMML, PyTorch. And natively, Chassis already supports a bunch of other things like Onyx and MXNet, LightGBM, XGBoost, those sorts of things. But we also have a list of requests that we've gotten from end users that we're racking and stacking for Q3. No promises, but right now the one that seems to be at the top of that list is Databricks. So that's kind of the tentative plan we've got going for Q3. And so hopefully by the end of this year, we'll be able to get the proxy support. You'll see not just SageMaker, but Azure as part of that cloud provider update and support, and explainability added on in along with some expanded ecosystem support. And with that, I think we'll take a little bit more first thing, one more thing before we come back to the Q&A. I said earlier that the full sort of advantage for Chassis is really going from the lab out to a deployment environment, and that there are two options when you come right out of Chassis, right? There's Kserve, which is an open source tool that you can set up yourself and have run if you've got the technical chops on your staff in order to be able to get Kubernetes up and going and you're familiar with it. The other option is for you to take the containers that come out of Chassis and submit them into Modzy, and they'll automatically run there. And so there is a version of Modzy that's like $5 a month that's online that we convinced our employers and bosses to give us discount codes for. So if you just want to try out taking your lab code, putting it in a container, and then placing it at an endpoint that can be hit anywhere from the world, then this QR code will actually give you, I think it's like 3 months worth of usage on that free, so you can actually try out the full latitude of Chassis. Yeah, and I think that is pretty much wrapping it up for us. So if anybody's got questions, I think we'll hang around a little bit longer in the chat. But other than that, I really appreciate you guys taking the time to reach out to us. I will make a shameless plug. If any of you guys if any of you guys are interested in what you see for Chassis and you want to actually contribute to it, go ahead and hit Saumil and I up on the Discord server. And we'd love to spend some time getting you oriented to the code and finding a few issues that would be good sort of starter issues for you guys. So other than that, thanks a lot for stopping by, and we'll stick around for questions here in chat for a little bit. So appreciate your time, guys.